Welcome to the fascinating world of fluid dynamics. Today, plunge into the exciting concepts of steady and turbulent fluid flow. These two types of flow bring to life the intriguing and complex behavior of fluids in motion, whether it be water coursing through a river or air circulating in our atmosphere. First off, define what is meant by steady and turbulent fluid flow. Steady flow, or laminar flow as it's often called, occurs when a fluid flows in parallel layers with no disruption between them. Picture a stream flowing gently down a hill. The water moves smoothly and predictably, with each layer of water sliding past its neighbors without mixing. On the other hand, turbulent flow is characterized by chaotic, erratic changes in pressure and flow velocity. It's what you witness when a river cascades over a waterfall or when wind whips up a storm. In turbulent flow, the speed and direction of the fluid can change rapidly, causing swirling eddies and vortices. Dive deeper into the realm of steady flow. The key to understanding it lies in its predictability. In steady flow, the fluid's velocity at a particular point doesn't change over time. This means if you were to measure the speed and direction of a fluid particle at any point, it would be the same no matter when you checked. This predictability makes steady flow easier to analyze and ideal for applications where control and precision are paramount, such as in fuel injection systems or the flow of blood in capillaries. Turbulent flow, however, is a whole different beast. It's characterized by its unpredictability. Unlike steady flow, the velocity of the fluid at a point in turbulent flow can fluctuate wildly over very short periods of time. It's a complex, chaotic system, but it's also incredibly common in nature and engineering. From the weather patterns that dictate our climate to the flow of water in pipes and the circulation of air around an aircraft wing, turbulent flow is everywhere. Despite its complexity, understanding turbulent flow is crucial because it influences everything from the design of airplanes to predicting weather patterns. So to summarize these key points, steady flow, also known as laminar flow, is characterized by its predictability and smoothness. It's where the fluid flows in parallel layers with no disruption between them. On the other hand, turbulent flow is marked by its unpredictability and chaos. It's a system in which the fluid's velocity can change rapidly and unpredictably, leading to swirling vortices and eddies. Understanding these two types of fluid flow is crucial, as they play a significant role in our everyday lives and in various scientific and engineering applications. From the blood flowing in our veins to the air circulating around a plane's wing, the principles of steady and turbulent flow are at work, shaping the world around us in ways we often take for granted. So the next time you see a river flowing calmly or a storm brewing in the sky, remember the fascinating concepts of steady and turbulent flow that make it all possible.